Hey guys, so we're working on convergent plate boundaries. And remember, convergent plate boundaries are when plate boundaries are coming together, and we're going to learn about three different types today. We're going to learn about ocean to ocean convergent boundaries. We're going to learn about when an ocean plate runs into a continental plate boundary, and we're going to look at a continental plate running into a continental plate. Okay, so first start here, we're going to hit two plates. And it'll take a second here to pop up. Maybe. It's taking a while for it to prepare it. There it is. All right, so we have two plates. Now, we're not going to draw continents on here because we're just worried about oceans, so don't worry about that. So go ahead and hit next. Okay, now we're going to assign our forces to our plates. Well, since they're convergent, we're going to draw our arrows coming together. Okay, so make that plate move this way, and then I'm going to move this plate to move that way, straight at it. So that's a convergent plate boundary, when plate boundaries are coming together. Okay, so there we have it. So now what you're going to do is we're going to hit next. Now we're going to look at plate density. Okay, so on plate density here, we're looking at the difference in density. This is important because when you have two materials that interact that have different densities, well, something's going to happen. All right, and we should already know this. So here I have plate 1, which is on my left side here. This is plate 1. This has low density. It's not very dense. Okay, plate 2, on the other hand, this side, on the right side here in the green, it is dense. Okay, so this is more dense. It's high density. Okay, so what you're going to want to do right now, take a quick screenshot of this and put into your Google form. I'm going to pause the video right now, so you can pause the video right now. I'm going to pause it. You should take a screenshot of this and put this into your Google form. Okay, so let's remember here, right, that our right side has more density. Okay, so let's continue on and play it. Hit finish. All right, as soon as it starts here, we're going to pause for 1 second. So pause your thing right there, right where it is there. Pause it and go right over here to menu. I'm going to click on menu. We want to see earthquakes, all right, and volcanic eruptions. All right, click on those, make sure they're on there. And then you can close that. All right. One thing else we need to notice over here, anything in the blue right here, if you notice right here on elevation, blue is ocean, 0 meters, that would be sea level. All right. And then it starts green. This is forming land. Okay. So anything of this is green, and then higher up, the dark brown, that's mountains. And then the top of the mountains would be a grayish white color. Okay. So make sure you understand that when you notice that. All right. So let's hit start. All right. So you notice what's happening. Something's happening. Our more dense plate on the right side here, all right, is sinking under our less dense plate on the left. Well, you notice what's happening on the left side. All right. So let's stop and pause it right here. All right. So let it run. Like I said, I let it run for about 163 million years, somewhere in that range. You can pause yours. And what do you notice? Right? On the side of the plate that's less dense, right? This is where we had all the earthquakes. The more dense plate on the right is now going underneath the one on the left. This is less dense over here. And so it's on top. And you notice that on the plate that's on top over here, right, I end up with volcanoes and earthquakes and land. This is an island arc that's forming right here. All right. So you can go ahead and pause and take a screenshot of this. All right, so what are some of the things we should be noticing here? I'm going to let mine continue to run, right? And that is that we're getting a lot of earthquakes, right, on the overriding side of the plate, and that we're also getting a lot of volcanoes, all right? And then it's also forming an island arc. On this side, we're getting islands that are forming on the overriding plates. Remember, this plate on the right side is more dense. It's sinking down. It's being subducted underneath. All right. So we would get earthquakes along this boundary. We would get volcanoes along this boundary. And also right along this boundary out here in the ocean where they meet, this is where we would get our deep ocean trenches. All right. This is where, all right, the deepest ocean trench in the world, the Marianas Trench, is occurring at a boundary just like this, where the ocean plate is going down underneath into another ocean plate, forming a trench right along this line, right at the boundary. Okay, so the four things: you have volcanic eruptions, you have earthquakes that are occurring at this boundaries, you have the formation of island arcs, and you also have deep sea trenches. Okay, so you want to put those on your paper.